I didn't teach bases in how long
Last time
though?
I did bases is in Form 2. That's the
When I
last
said
time I did that.
I didn't
The
teach
last time.
bases. I didn't teach bases for
Honestly,
like 2 years because like bases will never come. And then like all of a sudden just like, oh my God, bases.
only
Interesting.
base question I probably do is like back in SE though.
Had I not see it? Was
Yeah,
that a
and
while
just
ago?
like the thing with the 100 place and
Yes, the place
something like
values.
that.
Place values.
Yeah,
Mhm.
that's the last thing I know about. So
So here it is now. Let me look at the
yeah, this will go.
let me see how this will go. Um, before we do anything, do you all know what we call the base 10 number system?
Yeah.
What do we call
Excuse
it?
me, but what paper is this?
This is the 2026 paper.
January?
Yeah.
So and is it like ones, tens, hundred, thousand, something like that?
Yes. So
All right.
um the number system you are custom with is called the decimal number system or the denary number system. So decimal. And this is just simply base 10. This is base 10. So let me show you guys something quickly. When you're counting from, okay, we just be dealing with base 10 every single day, right? I have a question, guys. When we just start from zero and we just go to what? Like before we jump to a different place value, we just go from zero to what? Tell me, guys. You'd go from zero to
One.
what? Nah, decimal ordinary is the number system we're dealing with daily. So what I mean like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so, are you familiar with this?
That's
0
it.
to 9? Okay, so these are all the elements in the decimal ordinary number system. After that, you have to introduce a new place value and it's just recycling these digits. If you notice, we never truly actually counted 10. And what do I
Mhm.
mean by that? Nikolai, when you look at this, right? And you see numbers from 0 to 9,
Yes, sir.
let me ask that question. Is 10 a whole new number or is it just made up of digits in the denary system?
Made up of the digits in the numeric system. So
In the denary system. So 10 is actually not a different number. It's actually where you get when you have to move on to a different place value. Do you all remember place values in SEA maths or no?
That's it.
No? Yeah?
Yes, sir.
Okay.
Yeah, sir.
So Sky, after I count from 0 to 9, what would I move on to next?
And
I'll move on to 10, and what's after 10?
7, 12, 15,
All the way to what?
19.
All the way to what? All the way to 19, right? And
Yes, sir.
after 19, what would happen?
So you're going to 20.
All you see, what happening, right? I hope I'm making my point clear. The point I'm trying to make is in the decimal number system or the denary number system, the digits you have available is from 0 to 9. When you cross 0 to 9, you have to introduce a new place value, which is the tens place value. And if we keep going, eventually we'll reach what? Where would I have to introduce another place value? See if you can think about that. Where would I have to introduce another place value?
After 9.
100. 100.
Oh,
Okay, backtrack a bit. So, does everybody understand that in base 10, we go from 0 to 9? Those are the numbers available to count. Let me know if you understand that. 0 to 9.
Yes, sir.
Yeah, sir.
Okay, cool. 10 is not a different number, 10 is just made up of all the digits. It's just made up of digits from 0 to 9. So the way to think about it is a whole different number. So in the decimal number system, let me just give all some examples of some place values. Let's just say we had, I don't know, like 1, 3, 5, 4. Do you remember what place value this would be?
4,000.
Nah.
4,000. Is it?
Nah.
One.
Ones,
Yeah,
One.
ones.
This would be ones. What would this be?
10?
tens,
Tens.
100,000.
And this would be?
100. Ah, the opposite.
hundreds, and then thousands.
Yes. Now let me show you guys how this makes sense, right? I'm showing you all this because it's the exact same concept for all the other bases. I promise. So we're looking at base 10 here. Check this out. If we have 1,354, and I could write that as 1,000. Stay with me, right? I could write that as 1,000 plus 300. See if you're figuring out what I'm trying to do here. Plus what?
Plus 50, plus
Plus
40.
4.
Ah. So you realize that this is actually how much ones? How much ones would it take to make 4?
4 ones,
4.
And do you guys know how you would represent 1 as 10 to the power? Yes or no? I taking that as a no, right? Taking that as a no.
1 over 10, sir?
Nah, 1 over 10 is actually 10 to the power negative 1. What does ones represent? Let me show you. So 1 could be represented as 10 to the power 0. What do you think tens would be represented as? There's a pattern to be seen here. 10 to
100 to the power of 0, sir?
Nah. Tens is just 10 to the power 1. Where's 10 to the power 1?
10 by
10.
No, 10 to the
Yeah.
power 1 is just 10. 10 to the power 1 is just 10. You'll see where I'm going with this. What do you think hundreds would be?
10 to the power
10 to the power 2.
10 to the power 2. Guys, what does 10 to the power 2 mean?
10 by 10.
Where's 10 by 10, guys?
100.
100. Okay, what about thousands?
10 to the power 3.
Are y'all seeing what I'm talking about? Let me know if you
Yes,
see what
sir.
I'm talking about. After thousands, what we have?
10,000.
Right. And that'll be 10 to what power? What do y'all reckon? 10 to what power? 10 to the power 4. Okay, if you're confused and you need to tell me, right? We're building up to a very important concept here because this is the exact same thing you're going to use when dealing with questions like the one in 2026. Minimal memorization. You'll actually understand it. Okay, I feel like I'll at least understand this one. 10 squared is 100. Who here doesn't understand that? 10 squared is 100. Nikolai, do you understand that 10 squared is 100? Because 10 squared is 10 by 10.
Yes, sir.
All right. Sky, do you understand that 10 to the power 3 is really just 10 by 10 by 10? Tell me, Sky, do you understand that? Can I hear you, Sky?
Yes, sir.
Okay, I see you on mute. Darius, 10 to the power 4 is really just 10 by itself how much times?
4 times.
Right. So if that is the case, then 10 to the power 1, the power is 1, right? So that would just be what? See if you could figure out a pattern. What would that be? Look at the pattern. So 10 to the power 2 was 10 by 10. 10 to the power 3 was 10 by 10 by 10. 10 to the power 4 was 10 by 10 by 10 by 10. So what do you think 10 to the power 1 is?
10.
It's just 10, right? You're probably wondering, well, sir, where are you getting that 10 to the power 0 from? and I'll show you. Don't worry. All right, so Romano is Romano here. Romano, let me know if you're here. Okay, and I see in Romano that he's here, but I'm not hearing him. Nia, let me know if you're there.
Yes, sir.
Okay, so Nia, I'm gonna show you something here, right? And I want you to tell me if you actually understand this. So guys, we're gonna observe a pattern in maths here. If I want to go from 10 to 100, what would I need to do? Could any
Multiply by 10.
Okay. If I want to go from
Multiply by 10.
right, if I want to go from 100 to 1,000, what would I multiply by?
Multiply by 10.
Multiply by 10, sir.
All right. If I want to go from 1,000 to 10,000, I'd multiply by what?
10.
Multiply by 10, sir.
Right. I hope you understand that. Does everybody understand that 10 is the same thing as 10 to the power 1? Or no? If you don't understand that, tell me. I'll try to explain it. It's fine if you don't understand it.
Sir, when you say 10 to the power 1, I mean, but as the demonstration you just showed there, that is that like the continuous 10 by 10 by 10 by 10 by
Yes,
10?
it's building upon
It's
each other.
continuous?
Yes, it's continuous. So, Joshua, over here, we just have 10 by itself, right? 10 by itself. Just one 10. See that, right?
Yeah.
So I would say that's 10 to the power 1. Joshua, to get 100, I needed to multiply 10 by itself how much times?
One time.
Nah. I had to multiply 10 by
Squared.
itself how much times? Squared, right? So I had to multiply 10 by itself how much times?
10 by 10.
So I had
That's
to
10 from 2 times.
2 times, right? So the power is going to increase, so 10 to the power 2. To go from 10 to 1,000, I had to multiply 10 by itself how much
10
times?
cubed.
Exactly. You noticing a pattern here, right, Joshua?
And then 10 to the power 4. Quadrupled.
And here what? We're going to go backwards now. So, Romano, if I wanted to go from 10 to the power 4 to 10 to the power 3, what do you think I would have to do?
Divide by 10.
Right? I would divide by 10. If I wanted to go from 10 to the power 3 to 10 to the power 2, what would I do?
Divide by 10.
Well, you know this one about the powers. Tell me, Romano, what you know this about the powers?
Well, the power is decreasing as you divide by 10.
It decreasing by what? 4, then
It
3,
decreasing
then 2. By what number?
by 10.
By 1. Well, the power now, power is 1.
Oh,
Yeah. But what you say isn't wrong. It's decreasing. The power is decreasing by 1 because you're dividing by 10. Right? What would I need to do to go from 10 to the power 2 to 10 to the power 1? Somebody other than Romano. Guys, what do you think I would have to do? Anybody else in class? What would I need to do with 10 squared to go from 10 squared to 10 to the power 1? Ariel, what would I need to do? Okay, I was hearing somebody talking. Say that again.
So I just say divide by 1.
All right. Sky, what if we kept going? What if we divided by 10 again? What do you think is going to happen to my power? Tell me, Sky, what do you think is going to happen to my power? Did you notice that pattern here? 4, 3, 2, 1. So if I divide by 10 again, what do you think is going to happen to my power? Are you all seeing that pattern here?
Yes, sir.
Yes, sir.
What power do you think I'm going to end up with?
0.
Are you all seeing that? Yes or no?
Yes,
yes,
sir.
sir.
Right.
Yes, sir.
But I have a question, I have a question, guys. 10 to the power 1 is really just 10. So if I divide that by 10, what number is that? What number is that, Lex? Tell me.
0.1.
Nah, what's 10
One.
divided by 10? What is 10 divided by 10?
1.
1. So guys, I hope you see it now. This is why 10 to the power 0 is actually 1. And you know, like if we keep going, Darius, if we keep going, right? If we divide by 10 again, we divide by 10 again. What our power gonna become?
Will be minus.
Minus 1. Because as you notice, by dividing by 10, we're decreasing the power by 1, right?
Yes, sir.
So that 0 gonna turn to negative 1. And we know that 10 to the power 0 is what? What do we know 10 to the power 0 is?
1.
Right? And if you divide that by 10, you're gonna end up with 1 over.
10.
Yeah, you're gonna end up with 1 over 10. And let's see if it works in reverse, right? Let's see if it works in reverse. Guys, if I wanted to go from 1 to 10, what would I need to do? I'll wait in, guys. Come on.
Times by 10, sir?
Yeah. If I wanted to go from 1 over 10 to 1, what would I need to do?
Times by 10, sir?
By 10.
Right. So I hope we understanding the concept. Does everybody now understand why 10 to the power 0 is actually 1?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
If you don't understand, don't be scared and tell me. I will go over it how much times I need to just to make sure you understand. You just have to tell me you're confused. Chloe, you there? Chloe.
Yes, sir.
All right, Chloe, are you confused about the 10 to the power 0 is 1, 10 to the power 1 is 10, 10 to the power 2 is 100? Let me know if you're confused by that.
No, sir, I understand it.
Okay. Akira, you understand that?
Yes, sir.
You sure?
Yes, sir.
Nia, you understand it?
Yes, sir.
All right. So guys, if I were to ask you, what power does the tens correspond to? The tens is actually what? What is the tens actually? It's 10 to what power?
1.
Okay. What about the ones? The ones is 10 to what power?
0. 0.
Okay, I think I really get it. Nice. So this is very important. We're probably saying, why, sir? Why? Why is this important? Well, 1,354 is made up of how much ones? Tell me, guys, how much ones is 1,354 made up of?
1.
Well, if you look at the ones column, you see 4. 4. So it's really 4 ones. So to represent that, I could say 4 multiplied by 1 by 1 1. And that would be 10 to the power 0. All right. Now 50. How much tens do you think there are in 50? If you all had to
5.
say. So
5, sir.
I could write 50 as 5 multiplied by tens. How do I write tens? Tens is
10
what?
to the power 1.
10 to the power 1.
Right? Stay with me, guys. 300. How much hundreds does 300? How much hundreds in 300? So I'm trying to ask.
3.
3.
3, sir.
So I can write that as 3 multiplied by 10 to what power?
2.
2, sir.
And I can write 1,000 as 1 multiplied by
10 to the power
10 to
3.
the power 3.
right. And when we're doing this topic, you will see that depending on what base system they're using, you'll have like a small number at the bottom. So if we're dealing with base 10, you would see 1354 with a small 10 at the underneath. And that would mean it's in base 10. And so why did I just show you? Why did I just show you this? I showed you this so you would be able to understand place values and the importance of powers. Because you see that entire thing over there? I could actually write that as 1 by 10 to the power 3 plus 3 by 10 to the power 2 plus 5 by 10 to the power 1 plus 4 by 10 to the power 0. If you don't understand that, tell me, guys. Is there anybody that did not understand how I was able to split up 1,354? Vinaya, did you have trouble with understanding how I split up 1,354?
No, sir.
Nah. Regina, did you struggle to understand how I split up this number?
No, sir.
Akira, what about you? Did you
No, sir.
understand?
Yes, sir, I understand.
Chloe, you good?
Yes, sir.
Ariel, you okay?
Yes, sir.
Jelani, you okay?
Yes, sir.
Nia, you okay with this?
Yes, sir.
Nicola, you good?
Yes, sir.
Sky, how you feeling? My favorite child. My favorite child, apparently. My favorite child.
Sir.
You good?
So I told him I might give him problems, but yes, sir.
Okay. All right, well, Ariel, you good?
Yes, sir.
All right, cool. So make sure you have this copy down. Now, again, why did I show you this? This is very important when you're converting from other bases to base 10. Right.
So you can send this in the group chat after.
I send all the notes in the group chat after. Yeah. If I had that time I didn't send the notes, sorry about that. Just remind me. But I think I just always send the notes. All right, so guys, make sure you have this copy down, right? Let's look at binary now. That's one of the most common ones, binary, the binary number system. Anybody here does IT?
Yes, sir.
Okay, you understand that
Yes, sir.
Yes, sir.
computers run off logic, right? And
1 and 0.
logic is just on or off, 1 or 0.
Mhm.
So binary means base 2. Binary means base 2. But in binary, do you actually use the number 2?
No.
No, you don't. You don't. The same way in base 10, do you actually use the number 10? Is there even a number 10? Or is it that you just use the same digits and you just keep on going? Hear what I'm saying, right? Binary is base 2. When you're counting using binary, do you ever write like 1, 2, base 2? Do you ever use 2s?
No, sir.
No.
No,
Just zeros.
it's just zeros and ones, right? Same thing in
Yep.
decimal. When we're using the decimal number system, and we just recycle numbers from 0 to 9? Think about it.
Yes.
Like I wouldn't
Yeah.
write. Okay, if I wanted to write the number 11, would I write 10, 1? Or would I write I write 11. I just write 11. I feel like it's easier to understand for binary. You'll see what I mean. So when we're dealing with binary, the numbers that we have available to us is just strictly 0 and 1.
Excuse sir, but is this a new topic that we have to learn for CSEC maths?
It was always in the syllabus, It was just like at the crevices of the syllabus, and it never came. It came in this year though, and they brought it in the multiple choice. So I think you all should know it. I think you all should know it. In 2026, let me show you for your sake of believe it for yourself. Check it out, Joshua. Seeing that? 3,201 base 4 and 6,351 base 7.
And
So,
this is the first question.
yeah, first question, part 2. Right.
Hold on. So it's 4 over 7. The first one was 4 over 7 divided by 12.
Say that again?
The first question, part 1.
Wait. Yeah, 4 over 7 divided by 12. Yeah, but I noticed that in recent times, the basis questions coming now. So we should understand it.
Got the answer for that.
Okay, cool.
1/21.
Oh, we're not doing that question, eh? We're just looking at base number systems today.
No, but is that correct?
With 4/7 divided by 12?
Yeah. Oh man.
4 into 4 is
Sir,
1.
but
Yeah, 1/20.
no, sir, but shouldn't that have been flipped around? Because keep change flip 4/7 multiplied by 12/1.
No, 12 by okay. It doesn't look like it's over 1 right now, but 12 is the same thing as 12/1. So when you change the division to a multiplied sign, it's going to flip. It's going to turn 1/12.
So the last one remains as it is.
Say that again?
So the last thing in the division thing that remains as it is.
I cannot confused by what you mean by that. In division,
Yeah, in
you
the
flip.
fractions. The last thing it's saying, like in a question, like what you said there just now, with 12, 1/12, that remains same as is.
Yeah, because watch, right? Watch. The original question was 4/7 divided by 12. Now 12 is the same thing as 12/1. I didn't change anything there, Joshua. 12 is the same thing as 12/1. So now I will change the division sign to a multiplied sign and I'll flip it. And that would turn to 1/12. Yeah. You thought you had to leave it as 12/1.
Yeah.
Nah, you had to flip it. 12/1 is just the same thing as 12. All right. So 0, 1. Now let me show you guys how you would count using base 2. So if I had something like 0, let me just say we had 1, 0, 1. So Romano, didn't I show you how you could represent like split up numbers in base 10? You see that for yourself, right?
Yes, sir.
So Romano, this would have meant that you have 4 what? 4 what?
4 ones,
So that means you have 5 what?
5 tens.
Well, it's a very similar concept here in the binary number system. So let me show you how this would go. I'm not sure what you would call it, but it follows the exact same procedure, Romano. So you see this 1 over here? I would multiply that 1 by 2 to the power 0, and I'll add it to 0 multiplied by 2 to what power? What do you think? What do you think? I promise you it's the exact same concept as this over here. Instead of using 10, you would use base 2 because we're dealing with base 2. So, Romano, a way to apply the exact same concept. So this will be 0,
Use the power of 1.
right? And then lastly, it'll be 1 by 2 to what power?
2.
Yeah. So truth be told, this would be your 1's position. I believe this would be your 2's position. And we think, what position do you think that would be? If you had to say. If you had to say, try to figure it out. Romano,
Yeah.
try to figure it out. So think, and Romano, you could do this, 2 to the power 0 is just 1. We know that. 2 to the power 1 is just 2. So that'll be in the 2's position. And 2 to the power 2 is what? What's 2 to the power 2? You can do this. 2 to the power 2.
4.
4's. So what am I doing right now, Romano, is I'm actually trying to figure out what that would be in base 10. That's what I'm doing. What I'm actually doing right now is I am converting base 2 to base 10. That's what I'm doing here. So can you see that it is the exact same procedure with base 10. The only difference
Yes.
is that instead of using 10, what am I using now? Instead of using 10, what am I using instead of 10?
2.
All right, let me call upon somebody else. Darius, can you see that, like this is essentially the same thing as this? The only difference is I'm using 2 because I'm dealing with base 2.
Yes, sir.
All right, let me call some other people. Ariel, do you understand that in base 10, this will be your ones positions, this will be your tens, your hundreds, your thousands, etc.?
Yes, sir.
So Ariel, what if I told you it's the exact same thing for base 2? The only difference is, well, this one will remain as ones. This will be 2 to the power 0. Can you see that they are identical? The only thing that's changing is the base. Let me know if you're seeing that.
Yeah.
Okay.
Yeah.
After 2 to the power 0, what do you think would come next? Following the pattern.
2 to the power 1.
And 2 to the power 1 is what? What number?
2s.
Yeah,
Well,
2s.
2s will be a
2s, right?
2s.
2s.
Yeah. And 2
And
to the power 2 will be 4.
4s. So
Yeah.
Ariel, when we are counting using the binary number system, this would represent ones, this would represent 2s, and this would represent 4s. I'll show you a very cool trick just now. Right.
Yeah.
So Ariel, what are we doing right now? We are going from other bases to base 10. That's what we're doing. And we starting off with binary. So let's see how this would work out. What is 1 by 2 squared? What is 1 by 2 squared?
So we will calculate the 2 by 2 squared and then multiply 1 by that.
Yeah. So 2 squared is 4.
Okay,
What's 1 by 4?
so 1 4 is 4.
Right? And when we have 0, 0 by anything is 0. And 2 to the power 0 is what?
2.
Now, let me show
I
you
don't know.
something, right? Let me show you something, Ariel. What do you suppose 2 to the power 1 is?
2.
Okay. What do you suppose 2 to the power 2 is?
4.
What do you think 2 to the power 3 is?
Okay, wait. So would it be 0? So 2 to the
Yeah.
power 0 would be.
Wouldn't be
Okay.
0. Check the pattern, right? What's 2 to the power 3?
6.
Nah.
2
What is
2 is 4. And 4 2 is 8.
8? Now let's go
Yeah.
backwards. Let's go backwards, shall we? If you wanted to go from 2 cubed to 2 squared, what would you do? Okay, maybe we should start off somewhere else. So Ariel, let's just say you wanted to go from 2 to 4. What would you multiply by?
2.
4 to 8.
2.
Okay, so if you wanted to go from 2 cubed to 2 squared, what would you do?
Divide by 2.
Okay, what about 2 squared to 2 to the power 1?
Divide by 2.
Okay, and what are you noticing about the powers when you keep dividing?
They going down by 1.
Okay, so if I divide by 2 another time, what's going to happen to the power?
It'll disappear.
Well, it wouldn't disappear.
It
It's
would be
gonna
0.
be 0.
Yeah.
And remind me, what was 2 to the power 1?
2.
So if I divide 2 by 2, what would I get?
0.
Yeah,
Oh, wait, 1 1 1.
1. So
I don't
Ariel,
know.
did you know that anything to the power 0 is actually 1? Did you know that?
No, but now I know.
Yeah, check that in your calculator. Put 5 to the power 0. Or put 100 to the power 0. Check that for now. Put that into your calculator and you'll see that it's 1.
Yeah.
Alright, so I hope everybody understands that anything to the power 0 is just 1. So when we are counting in base 2, this actually represents 1s, this actually represents 2s, this actually represents 4s. I have a question. Nikolai, what do you think the next place value would represent? Let me see how bad it is, Nikolai. Let's just say I had a 0 over here. What would this place value represent? Let me see how bad Nikolai is. When Nikolai there, boy.
I hear, but I wouldn't say I was not bad enough.
All right, so Nikolai, you understand this perfectly? Like, let me know if you understand this perfectly, like base 10.
Yes, sir.
Okay, so Nikolai, if I were to add another digit over here, let me just say I add the digit 2. What I need to add to this?
You have to add 2 times 10 to the power 4.
Okay, let him cook, let him cook. I want you to apply the same concept here, Nikolai. What if I add another 1? Let's just add a 1. What I need to add to this?
Wouldn't that be 1 times 2 to the power 3 or something?
Right, where's 1 by 2? Where's 2 to the power 3?
That would be 8.
Right, so I would say that this is in the 8th place value.
So I was going to say 8, but then I thought that would have been wrong or something, but
No, that's correct. You see, Nikolai, when you're using the binary number system to count, this is how you're going to increment. So this would represent 1s, then this would represent 2s, this would represent 4s, and this would represent 8s. What do you think the next place value would represent?
12 or something.
Nah.
16s?
Yes, 16s.
Okay.
Because Nikolai, after 2 to the power 3, it'll be 2 to what power?
2 to the power 4. Okay.
Right. You see, look, you understand it. So we're going to do a bunch of questions on this to make sure you fully understand this thing. Because if you're not participating and you're not talking to me, you will get lost very fast. Yeah, you will get lost very fast. Jelani in class? Check Jelani.
Right here.
Oh, Jelani, you're here. Okay. Jelani,
Yeah.
you'll do a couple with me to make sure that I don't lose you. Because if you're not
All right.
participating with me, you will get lost. Right.
All right.
So yeah, I was asking Ariel, where's 2 to the power 0?
1.
Right. So this really means 1 by 1. 1 by 1 is what?
1.
Right. So 4 plus 1 is?
5.
Ariel, let me think about it logically, right, Ariel? Now in base 10, and it was very easy, like it was real simple, right? And when you look at this, you could see that it have 1,000, it have 300s, have 5 10s, and it have 1 1s. So altogether, it will give you 1,354.
Yeah.
Yeah. So if you wanted to get 5, wouldn't you need 1 1 and you would need 1 4? That's looking for a bit.
Okay, that makes sense.
That making sense, right?
Yeah.
Yes, Jelani, watch this, right? Jelani, if you want to make up 1,354, wouldn't you need 1,300,
Yeah.
5 10s, and 1 4?
Yep.
Right, look at the place values. We're going up in increments of 10. In the
Yeah.
binary number system, we're going up in increments of what?
2s.
Exactly. So this would represent 1s, this would represent 2s, and this would represent 4s. So
Yeah.
Jelani, if I wanted to count up to 5, then I would need 1 1s and I would need 4 1s. No, I need 1 4s. Because
Yeah.
where's 4 plus 1?
5.
Exactly.
Oh. Okay.
We'll do a couple more because it's really cool when you see it for yourself. So let's say we wanted to count up to 9. Let's just say we wanted to count up to 9, right, guys? In base 2. Let's see how we could do that. So Nia, you there?
Yes, sir.
All right, so Nia, I said your name correctly, Aunt? Nia?
Yeah.
Or is Naya? No, it's Nia. I want to say Naya.
Yeah.
I just
No,
want to say Naya,
Nia.
but it's Nia.
No.
Nia.
No.
Right. Nia, if I want to
Yes.
make 5, right? Wouldn't I need 1 and I would need 1 4?
Mm-hmm. Yes.
Okay. Let's just say we wanted to write 9 in base 2. Let me see how we could figure that out. Say with me, right?
Yeah.
All right. So, Nia, quickly tell me, right? In the binary number system, does it actually include the number 2 or does it just have zeros and ones?
Zeros and one.
Yeah, it just zeros and ones. There are no two. So here we're gonna happen, right, Nia? I'm gonna write ones here. I'm gonna write twos here. I'm gonna write fours here. What are you thinking of after fours?
8.
Yeah, eights. And guys, what are you thinking of after eights? Darius.
16.
Darius, after eights, you know you'd have 16s, right?
Yes, sir.
Okay. And guys, we want to count up to 9, and that's what we want to do. That's what we want to do, right? We want to count up to 9 in base 10. So if I want to count up to 9, what combination I could use here to get 9? Somebody tell me.
So you get 4 ones, use ones and fours.
You can't do that, you know. If you tell me 4 ones, you can't do
Wait,
that.
no, 8s and ones. Sorry, my bad.
Right, guys, when we deal with binary number system, what is the only two numbers we have available? What is the only two numbers we have available, guys, in binary?
Zeros and ones.
Just zeros and ones. So, I was talking to Nia, right? So Nia, tell me, Nia, if I want to make 9, what combination could I use here to get 9? And it could only... Say that again?
1 and 8.
Yes. So your number would look like... That makes sense?
Yeah.
Guys, I wonder if that makes sense. Did that make sense?
Yes, sir.
Right. So 9 in base 10 is actually just 1, 0, 0, 1 in base 2. And here it is now. Maybe some of them might have some trust issues. Or they might be saying, so I don't trust you. Well, we could verify it, right? So Nikolai, you there?
Yes, sir.
Right, so Nikolai, let's work this out using the long method. Long method, right? So you'll start off like this. We're starting off here, right? At the ones position. So that'll be 1 multiplied by 2 to what power?
0.
Okay. Then it'll be what?
0 times 2 to the power 1.
Plus?
0 times 2 to the power of 2.
Right.
And then the last one could be 1 times 10. 2 to the power 3.
Okay, guys, so this is the moment. Let's see if it actually works out. What is 1 by 2 to the power 3? Guys?
8, sir.
Yeah, Nikolai, 2 to the power 3 is 8. 2 by 2 by 2. Nikolai?
Yes, sir.
Yeah, and well, 0 by anything is what? What is 0 by anything?
0.
Right? Plus what?
1.
1.
And I'm gonna ask Ariel this. Ariel, what is 2 to the power 0? Ariel, you there? Okay, I'm not hearing Ariel, but Chloe, what is 2 to the power 0?
The 1.
Exactly. So this is effectively 1 multiplied by 1, which is 1. And guys, what is 8 by 8 plus 1? What is 8 plus 1? What is 8
9.
plus 1? 8 plus 1 is 9. So guys, what did we just do? We just converted 1001 base 2 to 9, to base 10, which is just 9. Do you all have a kind of a gist fit, like an understanding to some extent?
Yes, sir.
Okay, well, let me see if you all could figure out some questions before you start to use division. So, like, what about if I wanted to represent 11 in base 10? How would I do that? Let's see how bad all is now. Let me see how bad all is. Think about it logically. You could only pick one at the same time. Like, okay, you could only pick 1 8, 1 4, 1 2, 1 1. You can't pick more than 1 8, 1 4, 1 2, 1 1. So you need to figure out a combination. So how could you what digits could you combine to get 11 base 10? Think about that to yourselves. I'm giving you all
1, 8.
wait, I'm giving all you 2 minutes to figure this out. And you go just send me a message, send me an answer on WhatsApp. Is anybody figuring this out? Like what combination could give you 11?
You
Romano.
just said what combination could give you 11?
Yeah, so like look at this example, right? To get 9, you could use 1 8 and you could use 1 1. So like what combination would give you 11 in base 10? That's what I'm asking. Romano, you think you figure it out? Romano, so you have a 8 to work with, 4, 2 on 1. So like think about it, Romano. What I could use here to add up to 11? Think, Romano.
I think I get actually.
All right. Bet. Darius, that is correct. Big up yourself, Darius. Nikolai, you could figure it out, you know. You could figure it out, Nikolai. I know you could figure it out.
Sir, but like,
what
you don't really need a
it's a
paper for this, so.
one statement, sir, right?
Wait,
You
Darius?
say
Yeah, Nikolai?
you're saying what numbers gonna add up to 11, you say?
Yeah, and you could only pick like one. So like you can't pick 2 8s. You can only pick 1 8. That's what I'm saying. So
Okay.
like you pick 1 8, 1 4. Like okay, if you pick 1 8 and 1 4, that would give you 12 in base 10. Right?
Yeah,
If you pick 1 8 and 1 2, that will give you 10 in base 10.
yeah. We want to get 11.
I want to get 11.
Okay.
Nikolai, you think you have an answer?
I
Romano,
think it's something, but then the doubt is coming in my head, so
Nikolai, it have like no like okay, Nikolai, this I feel like it's real simple to see if you're correct or you're wrong, right? Nikolai, whatever combination you come up with, just add it and see if you get an 11. That's all. The combination
okay.
you're picking, Nikolai, is it adding up to 11?
Well, yeah,
Well,
but
if you're adding up to 11, then it's correct.
okay.
Don't overthink it.
No, it's like it's how we choose like two numbers and then add up to that.
You
It's
can't
like
pick two.
good.
Two wouldn't give you 11. Two numbers.
Right, so that I was thinking of now to go more than that. But then I was doubting myself and saying, what if this was wrong or what if this was right?
Okay, what answer did you get? I'm curious.
So this is all I thought, so I didn't write down anything yet. All right, I didn't know, so
Okay, but think to yourself, what combination would of 8, 4s, 2s, and 1s I could get 11? Think to yourself now. Let me do it together. By the way, Romano, you're correct. Let me do it together, Nikolai.
wouldn't it be the 8 plus the 2 and 1?
That is all. That is all. So to use a 8, a power 1 here.
Right. So that was that I was thinking of, but then it still come back to the thing if I was correct or if I was wrong.
No, boy, this is correct. You go use 0 4s, you go use 1 2, and you use 1 1. Guys, okay, Chloe, what is 8 plus 2 plus 1? Tell me, Chloe, what is 8 plus 2 plus 1?
11.
Right, Chloe, I want you to do one with me, right? Now, what I'm showing you all here is the intuitive approach to it. So this is like, if you understand it, you can figure it out like this. I'll also show you guys the standard procedure for CXC, but this, it wouldn't lose any marks. This is showing that you understand it at a deeper level. So Chloe, let's just say we wanted to represent 15 base 10 using binary. So, Chloe, what combination of 8, 4, 2, and 1 would we use to get 15?
So you could use 1 8.
Could use 1, 8.
2 4.
How much was?
No, you could use 1 4.
We could
1
only
4.
use 1 or 0, right? We could only use 1 or 0. You can either use it or not use it, right? So, yeah.
And mm, 1 2. 1 2 and 1.
Right. Now, let me explain something, guys. All of mine gonna be blown here. Guys, what is the next place after the 8s? What is the next place after the 8s, guys? Somebody tell me in class.
16.
16.
16s. So all you understand that all the digits filled up. So then it will reset and it will go on to 16 now. All you understand that?
All right, right. Yes, sir.
Yes. Let's soak in a bit now. Let's soak in a bit. Watch. Guys, if I wanted to represent 16, right?
Because it will just be 116 and the rest of zeros. Okay.
Exactly. That is it. That is it. Not so cool, eh? So Romano, what's after 8s?
Huh?
What's after 8s?
16s.
Right, 16s. So guys, if I wanted to represent 16 in base 2, how would I do that? Somebody tell me, other
Must
than
be
Darius,
or
other than Darius. Jelani, if I wanted to represent 16 base 10 in base 2, what combination
1
would I
0.
use to get this?
1 0 0 0.
Right, that's it. So do you all understand that over here, all of my digits are maxed out? So to count to 16, I'll go to the other place value. That is what is happening. Do you all understand that?
Yes, sir.
All right, Chloe, let me know if you understand that.
Yes, sir.
All right, somebody else I didn't hear from in a while. Akira, Akira, let me just say you wanted to represent 18 base 10 in base 2.
Right.
So you're using, how could you use the numbers here?
You could take out the 16 and put the 18.
Nah. So in base 2, so understand this, Akira. When you're dealing with base 2s, the values are increasing by multiples of 2. So you start off with 1, then 2, then 4, then 8, then 16. The values are increasing by a multiple of 2. So you need to figure out what numbers you could use here to make 18. So think to yourself, Akira, what could I use?
So enter
You could put 1 0 1 0.
That is correct. That's correct.
excuse sir, and it's supposed to have a each column.
The only
Yes.
reason I said 16 because I saw at the top when you do the 16, you had changed the. That's what got me confused.
Wait, yes, I'm supposed to have 8 columns. Where did the 8 go? Where did the 8 go? I guess somebody ate the 8. That makes sense. Right?
Yeah, that's why I was confused. That's why
My
I
bad,
said,
my bad.
yeah.
Yeah. Okay, is everybody okay with that?
Yes, sir.
Now, I have a tricky question for you, right? What is the highest number I could go up to using these place values as it is right now? Let me see how bad all it
31.
is. Wait, I hear one answer. What is it?
31.
Okay, how much people agree that with these place values as the highest it could go up to right now? Sky, do you think you could figure out what's the highest value you could go up to using the place values we have right now?
Yes, sir.
All right, so Sky, if we max out all the place values, it's either 0 or 1, right? So if I max out this, max out this, max out this, what is the number I'm going to end up with? See if you could figure that out for me.
So I can repeat that one more.
So, Sky, if I max out all of the digits, so let's just say I use a 8, I use a 16, I use a 4, I use a 2, and I use a 1, what digit am I going to get?
So I get 32 on my calculator.
Nah, it will be 16 plus 8 plus 4 plus 2 plus 1. 2 plus 1 is 3, 3 plus 4 is 7, 7 plus 8 is 15, 15 plus 16 is 31. That's what you do now.
So I missed out the 8, my bad. How would I get that for?
And Sky, let's try to understand why that makes sense, right? We should ask ourselves why it makes sense. Sky, if you notice, right, all of the place values are maxed out at the moment. You seeing that?
Yes, sir.
Sky, what is the next place value after 16s? So remember, this would be 2 to the power 0. This would be 2 to the power 1. This would be 2 to the power 4. This would be 2 to the power 3. This would be 2 to the power Sky. I make a mistake here, my bad. 2 to the power
5.
2 to the power 4. And what would the next one be?
2 to the power 5.
And what digit does 2 to the power 5 represent?
32.
Right. So Sky, do you understand that if you want to count further, you'll have to introduce another place value, which is 2 to the power 5. Do you understand?
Yes, sir.
Right. I feel like all your understanding basis.
Yes, sir.
Yes, sir.
Okay, cool. I want to do one more question before we do the exam, because you can do that right now, Using this concept, you should be able to do it. You should. All right. Let me ask somebody else. So Regina, you there? Regina, let me know if you're there. Can I hear Regina? Vinaya, you there?
Yes, sir.
Right, Vinaya, I have a tricky question for you now. Right. So Vinaya, let me just say we wanted to represent 70 base 10 in binary. It's gonna be rough, right? Vinaya, do you think that these would be enough place values to represent 70?
No.
Nah, because with the highest you could count up to if you use these set of place values. Do you remember the highest you could count up to if you use those values? Vinaya, talk to me. Let me know. If you forget, that's okay. We could
I forget.
say that again.
I forget the highest.
You forget?
Yeah.
All right. So Vinaya, do you understand that in base 2, the values are increasing by a multiple of 2? So we start off with 1s, 2s, 4s, 8s, then 16s. What do you think coming after?
32.
32. You say 32, right?
Yeah.
Right. So if 32 comes after, what do you think the highest number you could count up to with these is?
16.
Say that again?
16.
Nah, 31. Because the next place value would be,
Okay.
and even if you wanted to verify it for yourself, you could. Just hear what? Where's 16 plug this into the calculator for me. What is 16 plus 8 plus 4 plus 2 plus 1? Add up that and tell me what you're getting.
Excuse sir, where did you say that put our calculators?
16 plus 8 plus
Hold
4
on.
plus
Plus
2
4.
plus 1.
31.
31.
You get into the 1, right? And that makes sense because the next place value would represent 32. So the highest you could count up to with these values is 31. I'm going to follow you understand that. Are you understand now? Guys, Vinaya, let me know if you're confused or if you understand.
I understand.
All right, so Vinaya, do you understand that if I want to represent, Vinaya, let's just say we want to represent 18, right? If I wanted to represent 18, I would use 116, 1, 2, and 1, and 0. Okay, I would just use 116 and 2. That makes sense, right? Because we're 16 plus 2.
18.
What is this?
18.
Yeah, 18. So I want you to think to yourself now, how could you get 70? Do you think, do you think 32 would be enough? Going up to 32? Base 32?
No.
Okay, what was the next place value after 32?
64.
Do you think 64 would be enough?
Yeah.
I think so. So this would be 64. Then it would be 32. What next? I just write the digits.
16.
Bro, I just write the digit. Yeah, 64, 64, 32, 16. What next?
8.
Mm-hmm.
4. 2 and 1.
Great. And 1 is actually 2 to the power 0. 2 is 2 to the power 1. 4 is 2 to the power 2. 8 is 2 to the power 3. What is 16?
2 to the power 4.
What is 32?
2 to the power 5.
And what is 64?
2 to the power 6.
Right, so we need to figure out what combination could give us 70. So which one do you think we should use for sure? Like definitely. Which decimal place do you think we should use for sure? I mean, which place value should we use for sure?
64.
We should use the 64 for sure. What else do you think we should use?
Yes. 4.
Should use 4. And what else?
2.
Right. It's gonna be 0 here. 0, 0, 0. Yeah. Yeah, everybody understand that?
Yes, sir.
Yes, sir.
Right. Cool. And I have a question, guys. What do you think the largest number you could count up to with these place values before you move on to the next place value? What do you think the highest number you could count up to is? This is how battle is. Guys, what is the highest value you could count up to before you use the next place value? Nikolai, what do you think the highest number?
127.
Nikolai, do you agree with 127?
Yeah.
You see, I'm looking at your face and it's like, no, 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 no. I don't know what I'm on. I don't know why that is. Be honest, Nikolai, you're confusing.
No, and maybe at the same time.
Okay. Did you understand this example here, right? So like in this previous example, when we maxed out all of the place values using 16, 8, 4, 2, and 1, what we get? What we get, Nikolai? right? And what was the place value after 16?
Wait, what?
So if we use all of these place values over here, we use the 16, the 8, the 4, the 2, and the 1, we're gonna get to the 1, right?
Yes, sir.
What is the place value after 16?
The 18.
No? Don't worry about that.
Well, sir, I see the arrow, so I thought it was that.
No.
Uh,
Remember, we're going up in multiples of 2.
that would be 32 or something, sir.
Yeah, 32. So do you
Oh,
understand why we could only count up to 31 using these? Because the
no.
next place value is 32.
Okay.
Okay, watch. Watch this, right? Maybe it might make sense if I use base 10. 99.
Mm-hmm.
Hear me out, right, Nikolai? To make 99, what are you using? What place values are you using?
9. What do you mean what place values? 9 to the power 0 and 9 to the power 1?
Right, so I'm using 9 tens, right? I'm using 9 tens, and I'm using 9 ones, yeah?
Yes, sir.
But using 9 tens and 9 ones, I could only go up to what? Tell me, Nikolai.
Uh,
I could only go up to what? If I use 9 tens and 9 ones, I could go up to.
we talking about powers here or we talking about numbers?
I just talking about the raw value. 9 tens and 9 ones was the highest I could go up to.
10? Oh,
99.
9. Okay, okay.
Yeah.
Right.
So if I wanted to go further, I would have to introduce what place value. So I have 9 tens, I max out. Remember, Nikolai, if it in base 10, right, you could only go from 0 to 9. So you max out the amount of tens you could use, you max out the amount of ones you could use. Where you had to move on to next? If you wanted to count to 100, you'd have to introduce what?
9 hundredths.
Wait it,
9 to the power 2 or something.
wait it. So you have 99 here. And this is the highest number you can achieve with tens and ones. You understand that?
Yeah.
If I wanted to achieve 100, wouldn't it now turn to 100?
Yes.
Yeah. So to go from 99 to 100, wouldn't I just use 100s, 01s, and 010s?
Okay, I understand it now, sir.
Wait, let me run it back one more time. So Nikolai, right now,
Mhm.
I'm using I using the maximum amount of tens, right? I'm using 9 tens and I'm using 9 ones. The highest I could achieve with that is 99. You understand?
Yes, sir.
If I wanted to count 100 now, what place value would I need to introduce? So I have tens, I have ones. What would I need to introduce?
The hundreds.
Exactly. So you understand that using tens and ones, the highest you could reach is 99. But if you wanted to count up to 100, you would need to introduce what place value?
The hundreds.
Exactly, that's it, Nikolai. That's it. That's it. You understand
So
that?
I'm probably overthinking all of this because
I think so. I think so. And Nikolai,
yeah,
let me apply the concept here, right? So, what is the place value after 16?
it'd be 32.
Right. So, using these numbers, we think the highest I could count up to is.
It would be 31.
Yeah, it'd be 31 because if you want to count to 32, you'd have to use that. You'd have to move on to the next place value.
Okay.
So apply that same concept over here, right? I have
Mm-hmm.
I have 64, 32, 16, 8, 4, 2, 1. We think the highest number is I could count up to using these numbers.
70 or something.
No.
Oh, no. No. 64. 69?
Nah. That's a Nikolai.
Okay.
Let, let me check this out again, right, Nikolai? Let me use this simple
Yeah.
example here. What's the maximum number could I count up to using tens and ones? Just tens and ones.
99.
Right. You max out the tens and you max out the ones. You max out everything. Right?
Yes, sir.
Because they don't have such thing as 10 tens, right? Or 10 ones. No. 9 tens and 9 ones. So, Nikolai, if you were to max out, so you use that 64, you use that 32, you use that 16, you use that 8, you use that 4, you use that 2, and you use that 1. What you get?
Oh, we adding up all of that?
You don't have to, but if you want to see it this way, you could see it this way. Darius, I must give you props to seeing this one time, boy.
So as soon as you put down the place values, I was like, I can't believe I get that.
It makes sense, because to count, you would have to incorporate the other place value to count higher.
Wait,
Yeah,
sir, wouldn't it be 128? It was
Be
supposed
one-
to be 127, but the max. Wait, no.
You'll get 127. If you add up
Yeah.
everything, you'll get 127.
Okay.
And Nikolai,
Right.
that makes sense, because where's the next place value you had to go to count up to 128?
Yeah, I have to go
2 to the power
up
7.
to the power 7, yeah.
Right.
Now I get to that, okay.
Because using these numbers over here, I could only go up to 127. If I want to go up to 128, I need to introduce the other place value. That makes
Okay.
sense?
Yes, sir.
All right. So I think, and by the way, no matter what base it is, it's the exact same concept. Let me give you an example, right? What about base 4 now? Base 4. Let me look at base 4 quickly. Let's just say I had 1, 3. By the way, if we're using base 4, right? What digits do you think I could work with? Let me hear, guys. If I dealing with base 4, what digits do you think I could work with?
Four.
Okay, so with base 2, I could only work with 0 and 1. With decimal, I could only work with 0 to 9. So with base 4, what do you think I could work with? Nikolai? So, look at the pattern, right? For base 10, I could use 0 to 9. For base 2, I could use 0 to 1. So tell me, Nikolai, what do you think I could use for base 4? And anybody else could answer this?
0 to 3.
Yeah, Romano, 0 to 3. I feel like Nikolai real overthinking this thing, boy.
So actually, it have a reason why I'm not really functioning all that well, sir.
You okay?
Uh, no,
Don't tell me
but
that. Don't tell me the girl break your heart.
nah, sir. That is a virus, sir. The
Well,
new virus that came around.
well, they say heartbreak is a real dread virus, no boy.
So I'm not talking about that, sir, no, sir. I'm talking about virus.
Oh shucks. I just pulled in your leg, boy. I just pulled in your leg. What?
My head was hurting me like it was real hurting me yesterday. It's still hurting me. It's still hurting me now, but not as bad as yesterday. So
I understand.
it's like I'm trying to work with this and take my meds in between that, now, sir.
Well, big up you for joining class today. I know people in your shoes probably just stay out, like stay out of class. Big up you. But I see
Wait,
that
so what's up with the base tree? You don't know base tree in this?
it have here what it have base 1. No, it don't have base 1. It have base 2. You understand why can't have base 1, Because base 1 would just be 0. That can happen. So you have base 2, base 3, base 4, base 5, base 6, base 7. But you have hexadecimal, have anything. It have n bases. So the rule is for base n could be any number. Well, I'm gonna limit n. N has to be an element of It has to be whole numbers. Yeah. N has to be an element of whole numbers and real numbers. I should have a word for this. Basically, what I'm trying to say is the number, it needs to be positive and whole. Although I'm sure you could have fractional bases. Yeah, you could have fractional bases. I'll look into that, right? I'll look into that. But for base n, long story short, you'd be going from 0 to n minus 1. So like, Nikolai, you see it for yourself. If we're going up to base 4, then you go from 0 to 3. If you go into base 10, you go 0 to 9. Base 2, you use 0 and 1. Understand?
I understand, sir.
All right. So, Vinaya, let's just say you had a digit 3, 1, 2.
Okay, yes, sir. I understand it now. Yeah.
All right. 3, 1, 2, base 3. Vinaya, if you wanted to convert that to base 10, you think you know how you might do it? I promise it is the exact same concept as the last questions, like exact same concept. Tell me, Vinaya, I think you could be able to figure it out. Can I hear in Vinaya? Chloe, you there? Can I see in Chloe? Sky, you there?
Yes, sir.
Sky, let's try wait a. Yeah, Sky. 3, 1, 2 to base 3. Well, let's try to convert that to base 10. So I promise it's the exact same thing as the last questions. That's gonna be effectively 2 by what? So we're starting off with the smallest place value.
So 2 by 2 to the power of
Hold up, wait a minute, something ain't right.
yeah,
What base we working with over here? What base are we working with over here?
4.
Base 4, right? So that's gonna be 2 by 4 to what power?
Oh my gosh, yes. 2 by 4 to the power of 1.
Nah, look at all the previous ones. 2 to the power 0, right? 10 to the power 0. Remember, you're starting off with ones, and anything to the power 0 is 1. So it'd be 2 by 4 to the power 0. What next?
2
Tell me.
by 4 to the power 1.
1
And
by
then
1 by 4 to the power 1 plus.
by 3. I realized I don't know, so my brain not trying to
I
focus, but
understand.
3 by 4 to the power of
2. It just increasing in multiples of 4. So 4 squared is, I help all you out, right? 4 squared is 16. 16 by 3 is 48. 1 by 4 is 4. And 4 to the power 0 is 1. So 2 by 1 is 2. So you're gonna end up with 54. 54 base 10. I want to let you do this one for me. Try 3, 3, 3 base 3. Try that one for me. And wait, Nikolai, let me see if you actually understand this thing, right? So Nikolai, based on your observation, right? This digit over here would be what place value?
In the ones, so that would be 3 times 4 to the power of 0.
Yeah, that'll be 3 by 4 to the power 0. This is in what position?
In the tens.
No, we in base 4. We are in base 4. So what is 4 to the power 1?
4.
So this is in the 4th position. And
Uh-huh.
what position would this be in?
That would be in the 16. No.
Yeah, that'll be in the 16th.
Yeah, yeah.
Right. Now, Nikolai, think about it. Are we maxing out all of the place values?
No.
Here we are, because in base 4, where's the highest it could go up to? So check the pattern for all of them. Check it out, Nikolai. What's the highest I could go up to?
We could go up to 32 or
No. Okay. The highest value you could go up to is 3. 3. Now, watch this. This would be,
okay.
it'd be 3 1s, 3 4s, and 3 16s. Is the same logic for every single base. It's the exact same logic for every single base. So, Nikolai, let me do it together, right? So this would be 3 by 4 to what power?
Where we going from the first one in front or the one behind?
Front.
Oh, so that would be 4 to the power 3.
No, 4 to the power 2.
2? Okay. Oh, yeah. My
Because
bad.
we start off in the ones position in the back.
Yeah.
It's really
Okay.
0, 1, 2.
Yeah. My bad. So the next one would be 3 times 4 to the power 1. And then the last one will be 3 to the power 4. 3 multiplied by 4 to the power 0.
Right. Jelani, you there? Feel like I didn't hear Jelani in a long time. All right, Jelani, what's 4 to the power 2? What's 16 by 3? 16 by 3 is 48.
Oh, sorry.
What is 3 by 4?
12.
What is 3 by 4 to the power 0?
3.
Right? 48 plus 12 is 60, 60, 63. Now, this makes sense, you know. This makes perfect sense. Because, guys, Jelani, can you see that we're maxing out the place values as is? Why did I write 3, bro? Make a mistake here. Sorry about that. That probably might have caused some confusion. This will be base 4. So, Jelani, if we're in base 4, right? If we're in base 4, the highest we could count up to is what? Check it
16.
out. Where's in?
16.
Nah, 3. I know it's sounding confusing, right? If you're in base 4, the numbers, the digits you have to play with is from 0 to 3. If you're in base 10, 0 to 9. Base 2, 0 to 1.
Yeah.
The pattern is, whatever your base number is, the digits you have to play with is 0 to n minus 1. So, Jelani, this would be 3 multiplied by 4 to the power 0, multiplied by 4 to the power 1, multiplied by 4 to the power 2. And as you can see, we're maxing out the place values. So I have a question, Jelani. What would be the value for the next place value?
4 to the power 3.
What's 4 to the power 3?
32.
Nah. What's 4 by 4?
16.
What's 16 by 4?
It's 48.
Nah.
I'm sorry, 64, my bad.
64. Now, think about that for a moment. We maxed out all of the place values here, and so we got 63. For me to actually count to 64, I would need to go to the next place value.
Right.
Yeah.
And that would be
Darius.
4 to the power 5.
No, it'd be 4 to the power 3.
Okay.
Because what's 4 to the power 3?
That's 4 by 4 by 4.
What was that?
Sorry, I don't know.
64. I'll be 64.
64.
Right.
Yeah.
Darius, you see what I'm talking about? Or nah?
Yes, sir. Yes, sir. Yes, sir. Sir, this is light.
You like this topic?
Yeah, this fun thing. So I just think of it like a timer, you know. Like if you think about it, like cards, the amount of time you have to use a number is like -1 by the -1 the base. So like I just think about it like that. You know what I mean? Like you understand what I'm saying? Or no?
Cards.
Like the amount of times you have to use one number, and like if you have three of the same cards, like you know how is the base? You know what I mean? Or like
Okay,
a
okay.
timer.
Understand what I mean? I understand the timer especially. I understand the timer. There's a really cool illustration using a timer. I'll see if I can send it, but I understand what I mean. So what we've effectively done, it will be the same pattern for every single base. Every single base. So you're starting off with ones and then you're increasing in power. So let's answer the question in 2026 now. That should be light work. So Nikolai, I'm gonna call on you to help me with this because I know you're not feeling. I want you to understand this. So Nikolai, read part two for me.
Calculate the difference in value for the underlying digits in the numbers below. 3,201 to the power 4 and 6,351 to the power 7.
Right. So Nikolai, what is the base in this question? What is the base?
Base 4.
If it's base 4, then where's the digits you could actually play with? What digits?
0 to 3.
Perfect. 0 to 3. And what base are we dealing with over here?
Base 7.
Base 7. And base 7 would be from 0 to what number?
To 6.
And you're seeing that for yourself, right? The highest value is 6.
Yes, sir.
Now, if they want us to figure out the difference in value, what we need to do is we need to convert it to base 10 and find the difference. So, Nikolai, let's work with the 32014 first. Did my Apple Pencil just die? Yes, it did. Because we was going Sensi Form 4 class. All right, so Nikolai, let's reason it out. That one, right, Nikolai?
Yes, sir.
That'll be 1 multiplied by 4 to what power?
0.
Then the 0 will be 0 multiplied by 4 to what power?
1.
Then the 2 would be what?
4 multiplied to the power 2.
And the 3 would be what?
4 multiplied to the power 3.
Right, so doing that, Nikolai, you found the place value. So put that in your book. That'll be 3 multiplied by 4 to the power 3, right? And I want you to try and figure out what 6351 sub base 7 would be. Try to figure out the value for the 3. I think
That would be 3 multiplied by 7 to the power of 2.
Yep, that's it.
Okay.
And you just have to find the difference. And they get 3 marks.
So it's only when you show me, like when it's from 0 to 6, it have the number 6 there. It's only when I noticed that, like just now, you know.
I understand. Well, at least you understand it now. All right. I feel like Darius really like this topic, buddy. Darius real.
Yes, I experimented it.
Now, the ways I showed you all to work this out is highly intuitive. It's like the concept behind it now. But there's ways to standardize the concepts I've shown you all. So when you're converting like base 4 to base, when you're converting bases, you actually divide. You know what I mean by that shortly. You'll see what I mean by that shortly, right? So, Romano. Over here, right, Romano? This will be 0, 1, 2, 3. What am I trying to say, Romano? I'm trying to say that the 3 is really 3 multiplied by what?
3 multiplied by 4 to the third power.
Perfect. And this 3 now, that 3 is really 3 multiplied by
64.
wait, 3 multiplied by what? Oh, wait, you talking about the 3 over here. Wait, I'm moving on to this one now. So that'll be 3 multiplied by what? So over here. Tamara Romano. So what position is the 3 in over here?
Um,
So Romano, if you was to work this out, right, this would be 1 multiplied by, what's the base?
7,
So 1 by 7 to what power?
0.
Right? Then this would be what?
5 by 7 to the first power.
Right? Then this would be what?
3 by 7 to the second power.
Right? And this would be what?
6 by
Oh, yeah. By. Hey, whoa. Yeah, 6 by 7 to what power?
to the third power.
Right. So you see why I write 0, 1, 2, 3 here? So you can see that that would just be 3 multiplied by what?
3 multiplied by 7 to the second power.
Right. Where's 3 multiplied by 4 to the power 3? Mental maths. So 4 to the power 3 is what? Tom Romano, where's 4 to the power 3?
147.
Let me see. So 4 to the power 3 is 64.
No.
64 by 3. 64 by 3.
Wait.
64 by 3. So that'll
That'll
be
be 192.
192. Yeah. And 7 squared is 49. 50 by 3 is 150. 147.
Yes, sir.
You know how I all I do, I just say 50 by 3. 50 by 3 is 150. But I know that 49 is 1 less than 50. So, and 1 by 3 is 3. So 150 minus 3 is 147. That's how I do that. All right. So what's the difference, guys? So 192, that's 147.
No, not 45, 43.
Hmm?
45, sir.
45. Wait a
What?
Wait.
192 minus.
Oh, you're talking about the
Oh,
difference?
yeah, 45, yeah.
Because
Why is
45.
it 43? That's all. That's probably I write it wrong.
Yeah, so that's the answer. The difference is 45 base 10. Are you okay with that?
Yes, sir.
Easy 3 marks. Guys, if I don't understand this, I'll talk to me now. I'll explain it back again. I'll explain it again. Let me know. Are you understand this? Yes or no? Sky, talk to my Sky. Favorite child. How you feel about this?
So I understand. I wasn't understanding, but I understand it.
You wasn't understanding, but you understand now?
Yes, sir. On the other screen, like before, but on this 2026 paper, understand this one.
Okay, like, I'm not gonna lie, the stuff we was doing before was like very high level thinking. Because I feel like in school they would just show you the procedure and tell you learn that, but like,
I was not small thinking, listen.
yeah, it was
I
a
can
lot of thinking. It was a lot of thinking. But I wouldn't say it's hard. But this is the 2026 question. All you had to do was look at the place value. So this would be 1 by 4 to the power 0. Tell me, Sky, this would be 0 by 4 to what power?
power 1,
This would be 2 by 4 to the power,
2,
3 by 4 to the power,
3,
right? 1 by 7 to the power.
0.
You understand it? Nice.
Yeah.
And like, I don't think it was that hard to understand, Like, I feel like you could figure this out. Like what? Like this was an example of something that was confusing you?
So like when it is like I try to explain myself right so I could make sense. When you asked us to like put any places like 1000 or 1011, that part was I understood that part. But the parts where it's like so scroll down a little bit. I don't know where that was where it is like you have to like calculate the times. I keep thinking like if it's like 4 to the power 2, I keep multiplying 2 by 4.
Oh no, I feel like that's just like I feel like
But
that's
I
a
can
user error.
yeah, it is.
Because like you could plug that into your calculator. You could put it into your calculator and get the correct answer on a good day.
Yes, sir.
You can calculate it mentally on a good day. But like,
Yes.
watch this. If we Sky, if we're dealing with base 2, right? Then what digits we have available to count with? Base 2.
0 to 1.
0 to 1, right? Now, you'd have the ones position, which is 2 to the power 0. Then you would have the twos position, which is 2 to the power 1. You understand, right? 4, 8, 16.
Yes, sir.
So like, if I wanted to count up to 18 in base 10 using base 2, I would put a 1 by the 16, power 1 by the 2. That makes sense, right?
Yes, sir.
And like,
It's 16. 16 plus 2 is
say that
18.
again?
16 plus 2 is 18.
Yeah, 16 plus 2 is 18. And think about it, right? What's the highest number you could count up to if you max out all of the place values? So like here, what I mean, Sky? I mean like, if you use the 16, the 8, 4, 2, and the 1, what's the highest value you could achieve? The highest value you can achieve is 31. If you add it up, you go see you getting 31. But Sky, you understand that I can't get any, like, using these values, I can't get any higher. 31 is the highest value I could get.
Yes, sir.
Because I use any 16, I use any 8, I use any 4, I use any 2, and I use any 1. Sky, if I wanted to count any higher, I would need to move on to the other what? The other what?
Oh my gosh, I forget the
That's a P. Starts with P.
so my brain.
Ah,
But
help
I
me.
understand.
Place
So like
value.
same way, right? Place value. Same way I was gonna say if it's on 16 and I move to the other one is 18 and this.
Where's
Yeah.
the other one would be? Like if it's 16, where's the other place value? So this is 2 to the power 4. What would the other place value be? So look at the
32?
pattern. Yeah, it'd be 32, right? Because it'll be 2 to the power 5.
Yeah.
And that makes sense, Sky. That makes so much sense, right, Sky? Because
Yes,
I'm
sir.
saying the highest you can count up to if you max out this is what?
31.
And where's the place value right after that?
32.
You see, it makes sense. Sky, I'm not making sense.
It making sense.
Yeah, and it's the same concept over here now. What just? I was asking Nikolai this, and Nikolai was freezing up a bit because he's unwell. But look at this, right, Sky? First of all, you understand if I want to represent 70 in base 10 using binary, I would need a 64, a 4, and a 2. 4 plus 2 is
Yes.
6 plus 64 is 70. Yeah. Now, Sky, if I max out all the digits over here, so I use a 64, I use a 32, I use a 16, I use a 8, I use everything over there. Do you think the highest number I could go up to is? You think you know? Without adding up that, you think you could figure that out? Think about it, Sky. Where's the next place value? So if this place
Okay,
value is
no,
2
so I don't know why my brain keeps on multiply 64 by 2 and
Yes,
120.
that is correct. With
Okay.
64. Oh, okay. Because, okay, watch, right? 2 to the power 6. After 2 to the power 6, you'd multiply by 2 to get 2 to the power 7. Where's 2 to the power 7? Tell me, Sky, where's 2 to the power 7? Where's 64 by 2? Where's 64 by 2?
So that's 120.
Right. So, okay, if the next place value is 128, what do you think the highest number you could achieve with using the other place values before it? Think about it. You could do this. So if you use a 64, you use a 32, you use a 16, you use a 8, you use a 4, you use a 2, and you use a 1. What do you think the highest number you could achieve is? Romano, want you know the answer? Romano, you think you know the answer for this?
64.
No. Romano, if the next place value is 128, that means I could only count up to what using all of these numbers?
70.
Nah.
So 190.
So 127.
127. 127.
Oh, nah. I
Yeah,
rather so
Romano, add up 64, 22, 16, 8, 4, and 2, and 1. And tell me where you get. Because Romano, think about it, eh? If the next place value is 128, that means I could only count up to what? That means I can only count up to what here? If I use 64, 22, 6, 8, 4, 2, and 1. Romano, think about it. That means you can only count up to 127. If you want to count up to 128, you'll need to go to the next place value. Yeah. Sky, that makes sense?
Yes.
Think about it. If you want to count up to 100, and after you reach 99, what you gonna do? After you reach 99, what you gonna do?
Add one.
Yeah, add 1 and that would turn to 100. So you introduce another place value. But Sky, if you're just using tens and ones, if you're just using tens and ones and you max out the tens and the ones, will you ever get 100? Sky,
In this one?
if we dealing with base 10, like base 10, right? Base 10. If we're working with base 10, what numbers we could work with in base 10? From 0 to what?
0 to 9.
Right. So what's the maximum amount of tens I could have then?
9.
Right, I could have 9 tens, and I could have how much ones?
1.
9 ones. The biggest number I
Oh,
could
yeah.
use is 9. Biggest number I could use is 9. You think
Yeah,
I'd ever?
because 9.
Do you think
Yeah,
I'll
okay.
ever get 100? Do you think I'll ever get 100? If I use 9 tens and 9 ones, will I ever reach 100? Yes or no, Sky? Where's 9
No.
tens plus 9 ones? Tell me, Sky, where's 9 tens plus 9 ones? 9 by 10 is 90, and 9 by 1 is 9. Where's 90 plus 9? Things tough to
9. That's 90 plus 9?
Yeah, 90 plus 9 is 99. So, Sky, what is the next place value after tens in base 10? After tens is what?
Hundreds.
Right. So do you understand that the highest you could count up to with tens and ones is just 99? If you wanted to count up to 100, you'd have to use the next place value. It's the exact same concept here. You understand?
Okay.
Like, let's soak in for a bit, Sky. If I use 9 tens and 9 ones, that's the most amount of tens and ones I could use. I will get 99. But where's the next place value after tens?
Hundreds.
Right. So with tens and ones, the highest I can reach is 99. It's the exact same concept over here, Sky, because with 64, 32, 16, 8, 4, 2, and 1, the highest I could reach is 127. Because the place value after is what? For this one, what was the other place value, Sky?
128.
Exactly, it's the same concept. It's the same concept.
Okay, you making it cooking, no, it's cooking.
That's good, that's good. I tell you, if they don't engage with me this session, like, they'll be lost, so lost. Like, this is one of those things where you had to be like talking to me to understand and follow along. Otherwise, you're cooked. You're really cooked. Yeah. Right. Give me a second. Let me do this question. These questions really fast because they're very easy. We should be able to handle them easily now. Right, so convert each of the following binary numbers to base 10. Sure. So Romano, let's do this thing quickly, right? So Romano, I'm gonna start off. I'm gonna do the first question, which actually no. Romano, tell me what to do here. You should know. How would I convert this to base 10?
Wait, what?
How would I convert this to base 10? You've done it before. We've done it this class. How do I convert things to base 10? Let's observe. How did I convert this to base 10. So 101 base 2, which is 1 by 2 to the power 2 plus 0 by 2 to the power 1 plus 1 by 2 to the power 0, right? Apply the same concept over here, like nothing changed. It's the exact same concept, Romano.
Yeah, so it'll be 1 by 2 to the power of 0.
So I'm actually going to write 0, 1, 2, 3, 4, 5. So we're going to start off with 1 multiply by 2 to the power 0, right? Then plus what?
1 by 2 to the power of 1
Mm-hmm.
plus 0 by 2 to the power of 2 plus 0 by 2 to the power of 3 plus 1 by 2 to the power of 4 plus 1 by 2 to the power of 5.
Right. So, Sky, this easy. I'm gonna know Sky. Nikolai, Darius, Jelani. This question easy, right? Akira.
Yes,
Akira,
sir.
big up yourself. And Nia. I didn't know you were still here. Nia, you good? Joshua.
Yeah.
Right. Nia, honest. You're at lost. Or like, you understand.
No, I understand.
Okay, we'll help more with B then. Right?
Mm.
But if we work this out, 2 to the power 0 is what? What's 2 to the power 0? Guys, what's 2 to the
1.
power? 2 to the power 0 is 1. So this is just 1 by 1. This is just 1. 2 to the power 1 is 2. 0 by anything is 0. I could forget about that. Where's 2 to the power 4?
16.
Where's 2 to the power 5?
32.
32.
So it's really 32 plus 16, which is 48. 48 plus 50, 51. This is equal to 51 base 10. Are you understand? Because this is 32. 32 plus 16
Yes,
is
sir.
48. 48 plus 2 is 50. 50 plus 1 is 51. All right. So, Nia, help me with the other question. So, Nia,
Yeah.
how would I do this one?
So let's start off with counting from 0,
Mm-hmm. So,
1, 2, 3, 4, 5.
so yeah, we're going to do a little shortcut here to save some time, right, Nia? So,
Mm-hmm.
it's going to be 1 multiplied by 2 to the power 5 plus 1 multiplied by...
2 to the power 4.
Does it make sense to include the ones with zeros?
What's that?
Does it make sense to include the ones with zeros in it? Like, think about it, like over here, 0 by 2 to the power 3, 0 by 2 to the power 2. Do we even need to
No,
write that?
no,
'Cause 0 by anything is what?
0.
Exactly. So after 2 to the power 4, we can move on to what then?
We can move on to 1 by 2 to the power 2.
Right? Then plus 1 by...
2 to the power 1.
Right? I'm going to get the answer one time. So 2 to the power 5 is... I think it's 32. Yeah, 32, 16, 4, 2. Mental maths, 48, 52, 54. Yeah. Oh, let me just confirm this now. So 1 by 2 to the power 5 plus 1 by 2 to the power 4 plus 1 by 2 to the power 2 plus 1 by 2 to the power 1. So 32
Yes, sir. 58.
is 58. Wait, 32 plus 16 is 48. 48. You get 58 or 54?
Wait, sir, I think I do something wrong. Hold on a second.
Because 4 plus 2 is 6. 6 plus 16 is 22. 22 plus 32 is 54.
I get 54.
Yeah. Something wrong there. Right? Okay, Akira, you're still up?
Yes, sir.
What? In a way. Like you eat proper food, boy. Like you eat real food.
Yeah, I really eat this evening.
You, I'm not gonna ask you if you could share because I know you'll be hungry. So, all right, all right. I see you posting up like smoothies and thing on the TikTok. I was
Oh
like,
yeah.
that look like real greens though. That's real greens.
No, it's actually tastes good because you're adding fruits to it.
How to
So
try
you
that
know.
then?
Yeah, it tastes good.
Well, bet. So Akira, you see the shortcut by now, right? Like you start
Yeah.
counting from zero. So this could be
Yeah.
zero. What is it gonna be?
1, 2, 3, 4, 5, and 6.
Does it make sense to include the ones with zeros in it?
No.
Nah. So this could be 1 by 2 to what power?
1 by 2 to the power 6.
Right? Plus
1 by 2 to the power 4. 1 by 2 to the power 3. 1 by 2 to the power 1. And 1 by 2 to the power 0.
it's really easy, right? Like honestly, you can't tell me this
Yeah.
hard. Like, and you see the thing is the same concept for every single base, eh? So like Ariel did it. Or I think Ariel fall asleep. Or like she went back under the ocean. I don't fully get that joke. Anybody get that joke? Like Ariel, the mermaid.
Yes, sir.
Always really be talking nonsense in the chat, eh? I like that though. I had encouraging vibes. So somebody work this out in the calculator and tell me what you're getting. Let me see how far. Hey, somebody put it in the calculator and I'm gonna work it in my head. 2 to the power 6, that's 64. 2 to the power 4 is 16. 2 to the power 3 is 8. 2, 1, so that'll be 3, 3, 11, 11, 27, 27, 91.
91.
Yes,
Yeah.
sir, you're correct.
Yeah. So that'll be 91 based on. Oh yeah, I could do mental maths when you fly real good, but like you see when I go to the grocery and thing though, I just can't do mental maths there. Like you see somebody ask me a simple question, I just can't do that. I go freeze up. They go think I can't do maths. I went in the grocery at time and this lady had the audacity to tell me that I need to go back in school. I'm not good at maths. I was on question, but I said, nah. Let me not do that. Because I calculated my change wrong. And she was like, you know what, you need to go back in school and learn maths. That gave me so vexed, boy. Eh, But I didn't say anything. I'm a man of peace. Man of peace. All right, let me go. So let me do two of these questions. Now I showed you guys one way to work this out, right? So Romano, let's do the first question. Remember how to do it? The way I showed you?
Exclusive for number 60. What was the figure? What was the answer?
91. You got sure
Uh,
that?
hold on, sir. So, number 6 plus 1, 2, 4 plus 1 by 2, 3 plus 1 by 2, 1 plus 1 by 0. Yeah, that's
Bet. So Romano, you remember the way I showed you how to do this? So like if we want to count to 28, right? If we want to count to 28, 28. So like in base 2, you would start off with ones, then you would have what after ones, Romano? So you'd have like 1, you'd have 1, and you'd have 2. Then we have next.
Fours,
What next?
eights,
Then
16s.
you think we could count up to 28 using 16, 8, 4, 2, 1, 1, 1?
Yes, sir.
All right, so obviously we're gonna need our 16. What else are you gonna need?
Um, 8,
Mm-hmm.
4, 0, 0, 0.
Yeah, so 28 is 1, 1, 1, 0, 0 base 2. Guys, that was hard. Let me know if I understand that. No, they teach
Yes,
it they teach it differently in school. I'll show you how you will learn it in school.
so I never understand it in school until today. I trying to understand this like since I'm from three, and I
Same,
learned it in one day. I don't know.
same.
You see, like the thing is, in school they don't really teach you like the intuition behind it. But like now all you see the intuition behind it. So now the formula gonna make sense. But not really the formula or the procedure. So like this is the procedure I learned in school. So like 2 into 28. Gonna start off with 2 into 28. 2 could go into 28 with our how much times? How much time 2 could go into 28? Come on. 14. I remainder what?
0.
Right? Then 2 into 14.
You get 7.
Remainder.
0.
Alright. 2 could go into 7.
Times
Remainder of.
1.
Right? 2 could go into 3 how much times?
1 time.
Remainder.
1.
Right? And 2 could go into 1 how much times?
0.
It's a remainder of.
1.
Yeah. And you just put the numbers in order from in opposite order now. You get the 1, 1, 1, 0, 0. That's how we learn it in school. But when you learn it like this, I find like you don't see the logic behind it now. That makes sense. But the
Yeah,
logic,
whenever I see this on the board, my brain used to load.
but I mean the logic is there, right? But I feel like it's just kind of hard to see. What is there? Because you're trying to figure out how much twos could go into 28 going down the line. All right, let's do B now. So, Nia, to get 47, let's think of how we could combine let's see how we could combine to get 47. So, like, Nia, starting off with 1, then after 1 is what?
2,
What next?
4, 8, 16, 32,
Mm-hmm.
64.
We could stop there. Let me show you a way to remember this, right? Nia,
Yeah,
using the numbers before 32, the highest you can count up is to what? If you use the numbers before 32, what is the highest number you can count up to is? What's the highest number before 32?
31,
Exactly. If you use the numbers before 64, what do you think the highest you can count up to is?
63.
Exactly. So if you go up to 64, that could more than include 47. Actually, they even have to include, you didn't even have to go up to 64. Because our number is not more than 64. You understand?
Yes.
So like if you want to count up to 47, we'll include that 32. What next? Think about the combination.
8,
Is that 8? Okay. That'll give you 40. How you gonna get the 40? How you gonna get the 7? It's a question.
Hmm.
So maybe that's not the smartest choice.
Yeah,
If you add 32 and 16, what again? That'll be
48.
48. But that's too high.
Yeah,
So 4 plus 2 is 6.
6.
6 plus, let me think. Okay, I see it. 9. Let me see if this makes sense, right? So Yeah, let me see if this makes sense. So where's 8 plus 2?
10.
Wait, in my head, how could I swear it makes sense? 2 plus 1 is 3, right? 3 plus 8 is 11. 11 plus 4 is 11 plus 4, 15. Yeah, it go work. Where's 32 plus 15?
47.
Yeah. Let me check it one more time. I have trust issues. Where's 8 plus 4?
12.
Where's 12 plus 1?
13.
Where's 13 plus 2?
15.
Where's 32 plus 15?
47.
Yeah, so my answer is 1, 0, 1, 1, 1, 1. And this is base 2. Yeah.
Wait, exclusive. And
I hear so much ones are filled for ones on.
I hope you see this amount of ones in the exam script. That's what I hope.
exclusive. And how can they base numbers too?
Because they wanted us to convert from base 10 to binary. And binary is base 2. Yeah. And Joshua, in binary, the numbers would increase by increments of 2, by multiples of 2.
Oh, right.
So
Binary
one,
code ones and zeros.
yep. So like this would be 1 is really 2 to the power 0, 2 is 2 to the power 1, 4 is 2 to the power 2, 8 is 2 to the power 3, 16 is 2 to the power 4, and 32 is 2 to the power 5. Now if you use the method that you learn in school to do this, let me see how that will work out. So Joshua, I believe you learned it like this in school. So 2 could go into 47. How much times? How much, Joshua?
47 divided by 2.
Yeah, how much times could 2 go into 47?
246. No. 246, that's 204, 223, that's 13.
13?
What
Nah,
mean the W a one mean the
it'll be 23, right?
23.5.
Right, with a remainder of 1, right? 2 could go into 23 how much times?
223.
Yeah,
That's
that should be 11.
11. With
And
remainder 5.
nah, remainder of 1. Because 2 by 11 is 22. Remainder will be 1. Then 2 into 11 is what?
The 210 5, so remainder 1.
Right? 2 could go into 5 how much times?
204, 2, so that's remainder 1 again.
And 2 could go into 2 how much times?
1.
Remainder 0.
Uh-oh.
Yeah, 2 could go into 2. Yeah. 2 could go into 2, 1. Wait, give me a second. Yeah. So that'll just be
So therefore, sir, I will like multiplying every single number to the 2 1. So therefore, since
and
then the last numbers are equals to 0.
no, you have a point. You have a point. Because 2 could go into 2 one time, and then 2 into 1, that'll be 0. So the remainder will be equal to 1. And yeah, when it counted from last to first, you get 1 0 followed by the 4 ones. Yeah. All right, cool. Which method do you all prefer though? Like I'm curious to hear, Darius. Darius, which way is more intuitive, would you say? Can I hear Darius?
That's it. Definitely your way. I'm not even gonna try about that school myself.
You see, the thing is, I often like in this class, this is like the first time I'm teaching basis in like what 2 years. So like everything I do today was just like we just discover it. We just discover it. I'm being real. And just discover it. And that's the cool thing about maths. If you know what you're doing making sense, you can discover a lot of cool things. It's not to say like I have experience with bases. Like I feel like I understand the concept, and we could just explore it using sense.
So I could do the last question.
Sure, no problem. You wanna do it like the school method or like this method? Up to
Nah,
you.
your method. Definitely not the school one.
All right. So like 162. If it's 162, right?
Yep.
Then let me try to figure out what place we'd have to go up to, right? If we go up to 128, what is the number after 128?
256.
Are we counting up to 256?
No.
So maybe 128 should be enough, right?
Yep.
So now 128 is 2 to what power?
7.
So I could use 128, and it's gonna be 64, it's gonna be 32, it's gonna be 16, it's gonna be 8, it's gonna be 4, this would be 2, and this would be 1. Yeah?
Yes, sir.
Cool. If you want to get 162, maybe we should probably use the 128.
Yeah.
What is 128 plus 64? No, I can't use that.
No, you wouldn't use that. It's
Right.
0.
What are you thinking to use next?
32.
All right. 128 plus 32 is what?
That's gonna give you a 1. That's gonna give you
60. Make 60. Because 3
and then
plus
you add on 32.
you get the answer one time. This is crazy. This is goated. I'm proud of myself figuring this out in this class.
So,
Oh, I'll tell you, like up to today, I never knew this. Like I just figured it out in class. I'd even lie. Like if I figure out something for the first time, I'll tell you. But like I think all of them have this ability. You just had to like do whatever makes sense, honestly. If it's not making sense, don't continue. But yeah. And you get your answer one time. So what's the answer, guys?
10100010.
Yeah, bro. This is goated. This is goated. I'll make a TikTok video about this. But like for now, I'm taking a break from TikTok. But this is really cool. But the answer, so 162 base 10 is really 10100. Cool. For homework, I'll could finish out the other questions. Quickly though, guys, do y'all know how to do addition of binary, like binary addition? Or not? Or you know how to do that?
No, sir.
No,
No? Okay.
no.
What about like question 9, 10, and 11? So like convert the base 5 number 124 to base 10. So you want to convert, I think I only know how to do this. Like they basically asking you to convert 124 base 5 to 10. Or you know how to do that?
Yes, sir.
With that real simple, right? You would just say 1 multiplied by what? So like it's the same process. I'll say like 0, 1, 2. And where's the base? Where's the base there?
5.
So I'll say
5.
1 by 5 to what power?
2.
Right? Then I will say plus 2 by
5 to the power 1 and then plus 2 by 4 to the power 0.
4 by 5 to the power 0, and you get your answer one time, right?
Oh.
5 to the power 2 is 25. So 25 plus 35, 34, 39. I think it's 39. I verified that just now. So 2 by 5 is 10. 35. 35 plus 4 is 39. I'll go verify that. But I think that's the answer. Somebody help me with question 10 quickly. So we want to convert base 10 number 242 to base 8. So you want to convert to this is a bit different. It's a bit different. So we have 242. 242 plus 8. 242 plus 8 is 16. 16 plus 8 is 24. 24 plus 8 is 32. 32 plus 8 is 36. 36 plus 8 is 38. 38 plus 8 is 39. 39 plus 8 is 40. 40 plus 8 is 44. 44 plus 8 is 48. 48 plus 8 is 49. 49 plus 8 is 50. 50 plus 8 is 55. 55 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 base 10, and we want to convert this to base 8. Sure, no problem. This is very, very similar to how we would have handled the questions in question 7. Let me show you what I mean. So, Romano, if I want to count up to 242, right? Romano, you there?
Yeah.
If I want to count up to 242, let me think about the place values for 8. So I would start off at 1, then I would go to where? What are the place values for 8? So 1, that would be 8 to the power 0. What next?
8 to the power 1,
What next?
8 to the power 2,
Which is 64. What next?
8 to the power 3,
Which is?
uh,
What's 64 by 8?
Excuse sir, but
so
sir,
Wait, give me a second. This might be a bit cumbersome. I have to rethink. Yeah, Joshua.
we can calculate this can we do this via our calculators? Casio calculators, because there's in the equations in mode.
And there should be a way. There should be a way.
But would the correct one be deck?
Deck.
Deck. So therefore, if I say 242,
There should be a way, but I'll focus on that after. Let's try to figure out this question. Let's try to figure out this question quickly. Yeah, so Romano,
512.
512. Now let me ask that question, Romano. Are we going to go up to 512? Romano, are we going to go up to 512? If we want to write, if our number is 242, are we going to go up to 512?
Nah.
Nah, so we don't need 8 to the power 3.
Yeah.
Now, Romano, if we want to go to base 8, in base 8, what numbers we could work with? 0 to what?
0 to 7.
Right. 0 to 7. So this one might be a bit tricky, yeah? It might be a bit tricky. And the method in school might be the more practical approach here. So, Romano, if I want to make 242, how much 64s do you think I should take? Remember, I could pick from 0 to 7, right?
Yeah.
How much 64s do you think I should take? I would say like 164 is not enough. You would need more 64. So how much 64s do you think you should use?
Yeah.
If you
3.
use 3, I agree. You should use 3. Right? And if you use 3, right now you have to run in sum of 192. So like 192. All right. What next, guys?
Or 8.
So like you're saying 6 of this? Okay, so how far are we away from 242? 242 minus 192.
50.
We're 50 away, right?
All right.
50 away. My Apple Pencil just died. Guys, if we are 50 away from our answer, what combination could I use to get at? So I'm looking at 8 and I'm looking at 1. I could use what? I was hearing somebody saying the right thing.
6, 8, and 2 1s.
Yeah, you're correct. You're correct. Right, so Romano, where's 6 8s?
48.
Right, and to get the other 2, what you gonna use? How much ones are you gonna need, Romano? So you have 48, but you need 50. So how much ones you gonna need?
2.
Right, so 362. And that's the answer. So definitely harder. I'll show you guys the method you're supposed to learn in school. So 242 base 10, that'll be 362 base 8. Now,
Yeah.
if you were to do this using the method in school, I believe it would be 8, 242. Right? How much times could 8 go into 242? Somebody tell me. Plug it into your calculator.
30.25.
So it could go into 30 times, right?
Yeah.
What's your remainder?
2.
So Romano, 8 by 30 is 240. So the remainder is 2. 8 could go into 30 how much times?
3.
3. Remainder what though?
7.
7? Nah, 6. Think about it, guys. 8 by 3 is 24. The difference between 24 and 30 is 6. Yeah, you understand now, nah? Guys?
Yes, sir.
Okay, so here again, right? So 8 by 3 is 24. And our number is 30. 24 is 6 away from 30. Difference is 6. Right? And 8 could go into 3 how much times?
2.
0 times. 8 can't go into 3. 3 is a smaller number than 8. So your final remainder is just what? What you remain with? After all of this, what you remain with, Romano? So Romano, let me run through that one more time. So Romano, 8 could go into 33 times, and the remainder was 6. Could 8 go into 3? Could 8 go into 3, Romano?
No.
Nah, so you finish here, and you remain with what? What you end up with?
3.
Yeah. Then you just reverse it, and you get your answer. Yeah. So that was the way I learned in school. Right? So I will give you all the other questions to do for homework. But we should be a lot better in bases now. How are you feeling about it?
Very confident.
So once I do some more questions, so
Yeah, I need to do some more practice questions.
and not like our customs, like since Form 2, kind of rusty.
Well, I will find more questions for you guys.
I appreciate it. So it for sure to pop up in the 2026 June exam, right?
Yeah. This from the recent trends, it must.
Alright, okay.
Yeah. So I'll
You
send.
also told us, and you also told us that you was gonna go through some other topics. Like
What,
topics
today?
that have. No, yeah, I think you mentioned it, but just wanted to find out more about it.
Something I saw that I didn't see ever before. I saw rotational symmetry. But you know about that? All they ever do that in school? Rotational symmetry.
Nah. I think I saw that.
That was in the 2026 paper, and I was so confused. I never saw that in my life. Never. I'm being real. Like when I saw it, I was like, I didn't even know what this is. I mean, I was able to logically figure it out, but I don't think I see
Wait,
such.
excuse me. I was with the octagon and they told you the amount of symmetry and the next part was
Oh, yeah. We did that. We did that in school. Never mind. Yeah, we did that.
Like I being real with all like I never see that in my life. I never
But
do
now
that.
that polygons, right?
Yeah, it is.
Yeah. Well, yeah. I did that. For sure.
So I had created a summarized version of the syllabus here. And this is everything you should know in fine print even. So everything is here. And
So we could go through sets.
sets, I don't think
Yeah.
I'm gonna come any paper too, but sure, can go
I
through.
believe it could come.
You never know. I will go it over. follow your ask of it. It's fine. You could go over that.
Mhm.
Under geometry and trigonometry, section 8, under symmetry, yeah, you have rotational symmetry and order of rotational symmetry. So I'll send this on the group chat. Yeah, this contains
Yes,
everything you need to know,
sir.
right? I will. There's already in the group chat. I want to let you go through it and pick the topics that you don't know. You just have the most trouble with. Yeah.
So, you'll have class next week since everyone will be busy with mock exam.
I was gonna have class next week.
Okay. I think I can attend them thing because I have mocks next week starting.
Okay. Well, if the maths mock is soon, well, I could
I
always.
have mocks. I have Friday. I have maths mocks on Friday, so I'll probably join the night before.
All right, no problem.
Touch up on some stuff before I leave to go.
Well, guys, that'll be it for today.
So also, you think I told you about the statistics, the cumulative frequency.
when I get a chance, I'll check that because I had to wake up at really early in the morning, start school.
I see.
Yeah, but I will find more questions for you all on basis. But we feeling better about it.
Yep.
Okay, cool. So yeah, guys, hope you have a blessed night. Later, everybody. Take care.
Same to you,
Thank you, sir.
Yes, sir.
Yeah.
You too, sir.